Hello guys, welcome to Collegewali PADHAI. So today we are going to continue with the chemistry last class what we studied. So this one will come as episode 2. So what we studied last class was this equation, that is d square psi by dx square plus d square psi by dy square plus d square psi. It's not d, actually it's dou, but I am, while writing, I'm pronouncing it as d. Dou square psi by dou z square is equal to minus 4 pi square m square v square by h square whole into psi, where m is the mass and v is the velocity. Done. So till here we had studied. Now we need to move on to the next part. Till here we had studied. Now we know that kinetic energy is equal to half mv square, is equal to half mv square, and kinetic energy is also equal to total energy. Total energy is also equal to E minus V, where V is potential energy. So the equation which I showed you, dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square is equal to minus 4 pi square m square v square by h square whole into psi. So in that mv square, it was m square v square, but this is mv square, we can take it as 2 whole into e minus v. 2 whole into e minus v we can take in place of mv square. So then the equation will be, then what will be the equation, can anyone guess? Equation will be dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square equal to minus 4 pi square m by h square 2 bracket e minus v whole into psi. So this is the case. Now I will take this over here. Then instead of writing so much, I can minimize this as v square psi xyz plus 4 2s are 8 pi square m divided by h square whole to the power e minus v whole into psi. This can be written, and this is delta square minus Laplacian operator. I can write it over here. Delta square to Laplacian operator. Then we can write this as, let me write it below, minus h square by 2 pi square sorry, minus h square divided by 2m v square plus v square whole into psi is equal to e whole into psi. So what we will write that equation as minus h square divided by 2m v square plus v square whole into psi equal to e psi. So h can be written as h by 2 pi. H can be written as h by 2 pi, and h can be also called as Dirac. I need to write it correctly. Dirac, D-I-R-A-C. It's Dirac. So then this can be written as h like this is equal to minus h square by 2m v square plus v square. So the whole ending part can be written as h cap psi is equal to e psi. Done. So this was all about the Schrodinger wave equation. So now this is completed, Schrodinger wave equation. Then we will talk about the solutions of Schrodinger wave equation in one-dimensional box. So let's start talking about that. We move to the top of the board. Need to write it over here. Solution to solution of Schrodinger wave equation. The wave equation, solution of Schrodinger wave equation in one-dimensional box. Done. I think no underline part is there. Okay, so let me underline it myself. So this is the topic, solution of Schrodinger wave equation in one-dimensional box. So let me talk about some of the assumptions. So some of the assumptions are the particles cannot penetrate through the walls. Particles cannot penetrate through the walls. Or to be more clear, let me use the text box. It will be much more easier and clear. Why this is not doing? Okay. So I will use this whole text box. So what we are going to talk about? We are going to talk about assumptions. So what are the assumptions? First one is particles cannot penetrate through the wall. Particles cannot penetrate through the walls. The next, particles don't lose energy. Particles don't lose energy even on colloids, and kinetic energy is constant. Understood? So 2 points. First one is what? Particles cannot penetrate through the walls. Then particles don't lose energy even on colloids, and kinetic energy is also constant. Done. And let me also tell you about the boundary conditions. I think I should draw the diagram first. First, let me draw the diagram in black color. So this is, suppose, a vessel. Here V is equal to infinity. V is equal to infinity. X equal to 0. X equal to A. Here A. Here V equal to 0. And here V. Here X. So this is the diagram. So let me again move to the text box. So if I talk about the boundaries, so what will happen if I talk about the boundary? Any guesses? Means what will I talk about in the section of boundary? I will surely talk about what is inside it. I will also talk about what is on it. I will also talk about what is outside it and what is inside the boundary. So the range is from 0 less than x less than a. It's actually small a. Then on the boundaries, x equal to 0 and x equal to small a. Then outside is just the opposite of inside, 0 greater than x greater than a. So these are the boundary conditions. Now let me tell you about let me again write down the Schrodinger wave equation. So now the Schrodinger wave equation is dou square psi. It is a Schrodinger wave equation in one dimension, this one. Dou square psi by dou x square plus 8 pi square m by h square whole to the power e minus v whole into psi. So let's take the first case, that is inside the box. Let me start again taking the text part. It would be much more clear than the writing part. So inside the box, case 1. Let me write it as case -1 colon inside the box. So inside the box, what is there? V equal to 0. If V equal to 0, then what is the equation? Equation will be dou square psi by dou x square plus 8 pi square m by h square whole into e to psi equal to 0. So inside the box, if I am taking V is 0, then this will be the equation. And you can also write its or, not or actually, It is the value of psi. The value of psi is a sine. Please take a notebook or any rough copy and note this down. This is much important. A sine bracket 8 pi square m by h square whole into e whole to the power half x plus b cos, this is b, 8 pi square m by h square e whole to the power half into x. Let me write this correctly. b1 b. So this is the value of psi. Either write it down, and let me tell you, here a and b are both constants. A is a constant, b is also a constant. So next, let's move to our case 2, that is outside the box. Sorry. If you haven't taken a screenshot, please take it. Oh. So now I'm again using the text box for the case 2, that is outside the box. Outside the box, v is equal to infinite, as we don't have infinite symbol, so I have written it infinite. And I can also write the equation wala part. Let me use any other, okay, I'll use the black one. Dou square psi by dou x square plus 8 pi square m by h square e minus infinite whole into psi equal to 0. In place of v, I have given infinite. So again, more cases are there. Let me write it one by one. Let me tell you that the probability of finding particle outside the box is 0. Let me write probability of finding particle outside the box is 0. And same, probability of finding the particle on the wall is again 0. So there are two cases. Probability of finding particle outside the box, it's 0. Probability of finding the particle on the wall, it's also 0. So let's move on to the some equation part. If you haven't taken a screenshot, please take it. Okay. Then let's move on to the writing part. As we know that psi is equal to a sine 8 pi square m by h square e whole to the power half x. So this was the thing or condition what we can say. Sine, as we know, let me write the sine correctly. Sine 180 equal to 0. Cos 180 equal to minus 1. Sine 180 is 0. Cos 180 is minus 1. So then after this step, this x will become small a. Let's write the same thing over here. A sine 8 pi square m by h square whole into e whole to the power half into small a. Then as this a is not equal to 0, so we have to write only sine 8 pi square m by h square to e whole to the power half into a equal to 0. Then this part can be also written as, let me write in the red one, this one important part, sine 8 pi square m by h square e whole to the power half is equal to n pi by a, where n can be 0, 1, 2 or 3, anything. So what I've written, sine 8 pi square m by h square e whole to the power half is equal to n pi by, where the value of n can be either 0, 1, 2, 3, anything. Then the condition comes psi equal to psi of n. Then it will become a sine n pi by a. On comparing both the equations, we can get, this I will write in black, 8 pi square m by h square e is equal to n square pi square by a square. Understood? This is square. It's not being written properly. It's actually square. Let me write this before. This is actually square, square, square. So now value of En will be n square h square divided by 8m a square. So this is the thing. En is equal to n square h square divided by 8m a square. Then this till here, no doubt. Then let's move on to the next part, that is properties to the acceptable solution of Schrodinger wave equation. Let me clear the board. Cleared. Move to the top of the board as it would be much more easier. I'll write it over here. So now we are going to learn about properties to the acceptable solutions of Schrodinger wave equation. So now we will learn about the properties. So what's the first property? It must be continuous. It must be continuous. Then it must be infinite. Must be infinite. Then it must have a single value. It must have a single value. Then the last and the most important one, the probability of finding an electron all over space is equal to 1. Finding an electron all over space is equal to 1. This is one of the most important point. First one is what? It must be continuous, it must be infinite, it must have single value. Probability of finding electron all over space must be equal to 1. Then we can say that psi1, psi2, dot dot dot, these are all atomic orbitals. Atomic orbitals, and E1, E2, dot dot dot, these have corresponding energy. So these are three basic. Before that, let me write the Schrodinger equation in one of the most interesting manner. Just see. Ulta triangle square psi plus 8 pi square m by h square e minus v whole into psi equal to 0. Then this was all about that. Then let me tell you about the three quantum numbers. Everyone knows that each atomic orbital determines a quantum number. Let me write that. Each atomic orbital determines a quantum number. So there are almost around 4 types of quantum number. But today we are going to study only about 3 types. Those are, first one is the principal quantum number, which is also represented as small n. The second one is the azimuthal quantum number, which is also represented as L. The third one is the magnetic quantum number. Magnetic quantum number, which is represented as M. And the fourth one is spin quantum number, but we are not going to read about that. Can anyone say what is the work of azimuthal quantum number in the comments? Just think, or don't search in the web, just think. You must have studied in class 11th or 12th. What is the work of azimuthal quantum number? Because it's much more important over here. Forgot? Okay. So azimuthal quantum number describes about the shape of the orbitals, describes about the shapes of atomic orbitals occupied by the electron. So azimuthal quantum number describes about the shape of atomic orbitals occupied by the electron. Then let me tell you some of its about its shape. Azimuthal quantum number is represented by L. So let me write this in purple color. So when L equal to 0, so it is in which orbital can you say? When L equal to 0, it is in S orbital. It is in S orbital. When L equal to 1, it is in P orbital. Let me write this correctly, orbital part. Or B. When L equal to 2, it is in D orbital. When L equal to 3, it is in F orbital. So when L equal to 0, S orbital, so it is spherical in shape. This you need to mug up. It is spherical shape. When L equal to 1, it is P orbital. It is dumbbell shape. This is M, dumbbell shape. When L equal to 2, it is D orbital and it is double dumbbell shape. Double dumbbell shape. When L is 3, it is F orbital and it has a complicated shape. So you can note it down or take a screenshot. This is double, this is dumbbell, and this one is complicated. And this one is spherical, this is dumbbell. If you can't recognize the handwriting, I have to write this in pen only. Taken the screenshot? Okay. Means okay. Then let's move on to the next part that I have to write it with the help of text. That is probability of locating electron in space. Probability of locating electron in space. But actually, what is our motive? To find the probability of electron from the nucleus. Our motive is to find the probability of electron from the nucleus. So for finding the probability of electron from the nucleus, we have to deal with two factors. So the first one is radial distance. Radial distance from the nucleus. The second one is the angular direction from the nucleus. So mainly we have to deal with these two factors. So now I will show you a diagram from where the understandings will be much more clear. Let's begin with the diagram part. Which color? Black color I will use to draw the diagram. Two cubes, simple ones. Join these also. So this is Y, this is Z, this is x, this is theta, this is phi. So this is all about the diagram. So let me tell you that the wave function can be represented by x, y and z coordinates. But, stay. But when the concept of angular direction comes into being, then it's quite difficult for x, y and z coordinates. So what we usually do in angular direction, the Cartesian form, wait, let me write it in a proper manner, or I will use this one. So what we generally do, the Cartesian Cartesian form is converted to angular form. So when we are talking about angular direction, it is quite difficult to deal with x, y and z coordinates. So the Cartesian form is converted to polar form, not angular form. Sorry, by mistake I told polar form. Let me underline this, or someone will think it's angular form. Let me underline this in red color pen. Polar form. So how we can do that? X will be converted to R, Y will be converted to theta, Z will be converted to phi. So how can these be written as X, Y and Z? Let's see. Z can be written as R cos theta and Y can be written as R sin theta into sin phi. X can be written as R sin theta into cos phi. So this is about the fact. Written? Okay. Till here we complete. Now let's again continue with the part of Schrodinger's wave equation. So let me show. Okay. So what we are going to write? We are going to write that equation wala part. Delta delta plus 8 pi square m by x square to the power e minus v whole into psi equal to 0. Okay. So this one is basically the Schrodinger equation. This can be also written as delta square psi equal to dou square psi divided by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. This can be also written as this. Then we can write phi is equal to f of x, y, z. Phi can be written as f of x, y, z where where psi is equal to r theta theta and phi of phi. When we are bringing psi is equal to f of x comma y comma z, then psi can be also written as r of r, theta of theta, phi of phi. This can be also written as r nl of r a ml. So this basically depends on distance from nucleus. This depends on quantum number. This tells you about radial function. This tells you about angular wave function. Let me write it in the red pen. This tells you about distance from nucleus. This tells you about quantum number. This tells you about radial function. And this tells you about angular wave function. Angular wave function. Understood? So now let's discuss some of the important topics. No, I will tell you about some facts. Just like psi, our R has no physical importance, and R square is the probability of finding the electron. Let me repeat. Just like our psi, R has no physical importance, and R square is the probability of finding an electron. We can write it as 4 pi R square or 4 pi R square then capital R square, which is also called as radial distribution. Radial distribution. So R square is the probability of finding the electron, and we also written as 4 pi R square or 4 pi R square capital R square, which is also called as radial distribution. So let me tell you about some of the key facts for which I have to use the typing. Important key points. First one is the probability of finding electron of finding an electron from the nucleus is 0. So the first key point is probability of finding an electron from the nucleus is 0. So the second one is, can anyone guess? It's related to any quantum number. Yes. So the distance from the nucleus increases No, I can also write like this. Principal quantum number, principal quantum number increases with increase in distance from the nucleus. So this is the second one. Principal quantum number increases with increase in distance from the nucleus, and they both are directly proportional. So let me write the third and the last one. Radius decreases. Radius decreases with increase in azimuthal quantum number. So what was the last point? Radius decreases with increase in azimuthal quantum number. So these are the three key points which you must remember. So this is the end of today's class. So all I want to tell you, as I tell in each and every video, is a big thank you. Do subscribe the channel, like the video, comment what you liked about the video, which topic or concept, share the video. Thank you.